Now, what would be nice is if we could demonstrate the power rule for all exponents, for rationals and irrationals, as long as our base value, our x value, is greater than 0. So here's what I mean. Let's say we had a function f of x, and it was equal to x to the n. Now, in the past so far, we've said that n is an element of the rational numbers. So we've proven this in case this guy up top is like, oh, I don't know, 1/2 or 3/4 or 7/5 or 2 or -6. Okay, you get the idea. Okay. Now what we haven't shown is what if this guy can't be written as a fraction? Well, now what we're going to do here, we're in a position to rewrite x to the n as equal to e to the natural log of x to the n, because this function and this function are inverses. As long as this guy right here is greater than 0, we're good. So now what we're going to do is we're going to use our rules of our natural logs, and we're going to go ahead and say that this is e to the natural log of x times the variable n. Okay, nothing wrong with that so far. Now this holds as long as x is greater than 0. So now what we'll do, and this also, n can be any number it wants to be. Okay, so now what we'll do is we'll take the derivative. So d dx of this guy right here, e to the natural log of x times n. I'm going to do a substitution. Let's let u be equal to the natural log of x times n, okay, where n is a real number, any real number. So du dx, let's just find that one right away. That is n over x. Well, it's really n times 1 over x, so I can just reduce it like this. So this guy becomes d dx of e to the u. And we know that we have to switch this here, so this becomes du dx times d du of e to the u. Now du dx is n over x, and d du of e to the u is just e to the u. Well, we know e to the u is equal to e to the natural log of x to the n, because that's what u is equal to. And we know that this right here is equal to x to the n. And so what we have is n times x to the n over x, which is n times x to the n minus 1. And so we've found the derivative for any value of n, not just the specific rational numbers we're looking for. So for example, give me a second, Ben.
Are you hungry?
So like, let's say we had something like this. Oh, I don't know, f of x is equal to, let's say, x raised to the square root of 2. Now normally we couldn't just drop the square root of 2 down there because we didn't have a rule for these guys if they were irrational numbers. But now we do. So now we see that it follows the same exact rule as if this guy was just any other ordinary number, any ordinary rational number like we've been working with. And so there it is. So what we've done is important. You might just look at this and you might say, well, look, who cares? It's the same exact thing. I'm doing the same exact rule. Yes, but now we have a foothold, a justification for using it, whereas before we didn't.